Chapter 2. Quantum Tessellation of Space and Tripartition of Strings. 2.1. The Modern Ether, the Dynamic Lattice of Strings, the string as a binary oscillator. CQC rejects the concept of cosmic vacuum as a pure geometric abstraction lacking structure. Three-dimensional space is a tangible and dynamic medium, a self-organized grid composed of quanta of fundamental geometric excitation, open strings. This lattice of strings constitutes the modern ether. The strings nucleated during the collision strictly divide into three fundamental topological classes. Base strings. Open strings having both endpoints free to slide on the surface of the brain, interconnected head to tail, to form the background geometric texture. The local density of these strings determines the physical metric and the perception of distance. Matter strings. Open strings having one or both endpoints anchored. They manifest as elementary particles endowed with mass and localized energy. Gravity strings. Closed strings unconstrained to the cosmic brain and therefore free to move and propagate in the multidimensional bulk. They act as gravitational mediators. In the previous chapter, we established that space is not empty void, but a grid of space strings connected head to tail. How do we mathematically describe a single string of this grid? In quantum mechanics, the state of a system is written inside a bracket called a ket, introduced by Paul Dirac. In our model, every building block of space is an oscillator that has only two stable fundamental states. The vacuum state 0. The string does not vibrate, it is taut and stable. It possesses only the minimum 0-point energy. The excited state on, the string receives energy and begins to vibrate at its fundamental frequency nu 0. Mathematically, the general state of a space string at a given moment is a linear superposition of these two states, psi equal tolfa 0 plus beta 1, where alpha and beta are complex numbers representing probability amplitudes. If we calculate the squared modulus alpha 2 and beta 2, we obtain the probability of finding that string on or off. If you recall vectors in linear space, this is exactly like describing a point on a plane using two orthogonal Cartesian axes, the axis of vacuum strings and the axis of excited strings. 2.2. The binary code of the quantum vacuum, wave propagation in the lattice. The three-dimensional grid formed by space strings operates as a fundamental quantum processor with discrete states. Every single string element of the spatial lattice is described by a binary quantum state in the local Hilbert space. Vacuum state 0 corresponds to the string in its ground state of minimum vibrational energy. It possesses no measurable charges or excitations, but defines the geometric continuity of space. Excited state on corresponds to the string that has absorbed a quantum of vibrational energy equal tau nu eon. This state represents the localization of an energy fluctuation or the transient presence of a virtual particle. The propagation of a field or electromagnetic radiation in the vacuum does not occur via the displacement of a particle through empty space, but through the sequential transfer of the excited state known from one node to another within the binary lattice of space strings. Now let us take a step forward. What happens if a string turns on and transmits its vibration to the adjacent one? We obtain wave propagation. In the 19th century, to describe waves in the ether, or on a stretched guitar string, the classical wave equation was used. x2 phi, ct2 phi. In modern physics, if we wish to include quantum effects and mass, we use the Klein-Gordon equation, phi equal to 0. The symbol is simply an abbreviation denoting the second derivatives with respect to space and time seen above. How is this equation interpreted in CQC? If the string is free, it has no anchored mass. The Klein-Gordon equation reduces exactly to the classical wave equation. The vibration moves at the maximum speed permitted by the stiffness of the fabric, which we call c. If the string is anchored to the brain, the anchoring acts as an elastic brake. This brake introduces the mass term μ into the equation. The vibration can no longer travel freely at speed c, but remains localized, behaving like a particle endowed with inertia. 2.3 Black holes as geometric phase converters, thermodynamic conversion of black holes. CQC resolves the paradox of the gravitational singularity inside black holes. A black hole is not a mathematical singularity of infinite density, but rather a thermodynamic phase converter that transforms matter into geometric space. When stellar matter collapses beyond the critical density limit, the matter strings confined on the brain experience tidal forces and excitations so extreme that they trigger a phase transition, and phase transitions plus G. Breakage of Dirichlet constraints, the endpoints of matter strings anchored to the brain are literally detached due to the extreme energy density of gravitons concentrated at the event horizon. Head-to-tail fusion, deprived of its anchorings on the brain, the matter string loses its intrinsic physical properties of mass and charge. Its free endpoints instantly fuse head to tail, converting it into a space string. External metric flow, the black hole, by converting collapsed matter into space strings, expels the latter radially outward. This constant flux of new geometry prevents the formation of a central singularity and guarantees the perfect conservation of quantum information, which is encoded in the micro-oscillations of the ejected space strings. Let us apply this physics to a macroscopic object, the black hole. In classical physics and general relativity, matter falls into the black hole and accumulates at a point of infinite density. In CQC, as established, the black hole breaks the anchorings of matter strings and converts them into space strings, which it then expels. We can imagine this process as a thermodynamic phase transition, akin to an ice cube melting into liquid water. Let us define the mass of the black hole as m. The rate at which the black hole ingests matter from its accretion disk is dTd-min. The rate at which it converts this matter and expels it in the form of new space strings is linked to the surface area of the event horizon. We can write the mass-energy balance equation of the black hole as dTdm equal Tod Tdm sigma a horizon, where a horizon equal Tok is the area of the black hole's event horizon. Sigma is the geometric conductivity constant of the horizon. What does this equation signify? If matter enters the black hole grows. However, as it grows, the area of its horizon also increases, meaning it continuously converts and expels more space outward. This establishes a natural dynamic equilibrium. It prevents mass from collapsing infinitely into a point, because excess energy is continuously pumped out in the form of a new geometric grid.